Welcome to the second day of a mathematical model class. Today we will learn apportionment. We'll learn the apportion model two different ways. First, we're going to learn it conceptually, and then we're going to learn using mathematics. We will use the historical aspect to learn the apportion conceptually. Use at least three example: Hamiltonian method, Jeffersonian method, Webster method. Hamiltonian method, Jeffersonian method, and Webster method will allow us to understand the apportionment mathematically. So let's get started, and we'll start do now. Do now. The first problem of the do now is like about 2016 election. Mr. Trump won the more electoral votes, whereas Mrs. Clinton won more popular vote. Who should win the election? Well, this is a matter of opinion. In my opinion, Mrs. Clinton should have won the election, so I'll choose Mrs. Clinton. The second question: if we use plurality method, who should win? We understand the plurality method last class. So we also understand that people or candidate receive most vote win the election. So if you use a plurality, Mrs. Clinton. Who would win in terms of majority criterion? Candidate who receive most vote of first place vote. So the A, and then who should also be Clinton. Now we are moving to a less controversial topics. And what year were the three branches of government created? 1787 in Philadelphia during the Constitutional Convention. Now fill in the blank. So 1887, the Constitutional Convention in Philadelphia, delegates of the 13 original states created a system of government with three branches: legislative, executive, and judicial. However, there was a problem with the representation of the legislative branch. There was no problem with executive, and there was no problem with judicial. There was a problem with legislative branch. A smaller state wanted equal representation. In response, a Senate in which two senators represent each state was created. Larger state preferred proportional representation. Thus, a House of Representatives in which each state received a number of representatives proportional to its population. Unfortunately, the founding father did not decide on the exact number of the representative for each state. In fact, Article 1, Section 2 of Constitution states, representative shall be apportioned. So we are talking about the apportion. So apportion among the several states according to their respective numbers. The number of representatives shall not exceed one for every 30,000. So one for every 30,000 people. One representative for every 30,000 people. Each state shall have at least one representative. Historically, at least 4 apportionment methods have been implemented: Jefferson method, Webster model, Hamiltonian method, and Hill-Huntington method. So that takes us to the next part, and that is the mini lesson where we will understand apportionment using mathematics. Now, this problem will allow us to understand what is fair. Fair means something that is legit. And what is legit? Let's understand it not by using English word, by mathematics. A problem: So this is the City College. City College of New well, not City College. City University of New York has 27 branches. City College is one of the branches. So 27 colleges. So in 1999, there was $1 billion granted to City University of New York to allocate to give all 27 branches. Now, what would be the most fair way of allocating that money to all 27 colleges of City University of New York? We will try to understand that. Okay, so if we use the math, it's very simple. $1 billion divided by 27, and that gives us $37 million. That gives us $37 million. So each college received $37 million, and 37 million times 27 should be $1 billion. Now, is this fair? Now we are talking about the fair distribution. Is this a fair distribution? No. Why not? Because the CUNY has a college like I don't know, BMCC, where student population is 30,000, and CUNY system has a college like CUNY Graduate School of Journalism. CUNY Graduate School of Journalism is a joke. It has only 100 students. So would it be fair to give BMCC $37 million at the same time the CUNY School of Journalism that has only 100 students $37 million? No. So how can we make it a little bit more fair, to the colleges that has more population? Well, let's try the second way. And how can we do that? So let's say CUNY School of Journalism, as we said, that it has 100 students. So 100 divided by the whole CUNY population. The CUNY population, I checked it last time. I'm a CUNY student. I went to almost all CUNY school. Either I went to earn the degree or I taught. So I know CUNY more than, well, I know CUNY. Okay, so 500,000. So total student of CUNY is 500,000, and the student at CUNY Graduate Center for Journalists is 100 times 1 billion. Zeros, 1, 2, 3, 4, 5, 50, 1, 2, 3, 4, 50 cancel. 5 goes to 20, 20, 1, 2, 3, 4, 1, 2, 3, 4. So $200,000. So $200,000. So CUNY Graduate School of Journalism actually deserve. It doesn't deserve $37 million. It deserves only $200,000, less than 1 million. Why it deserves this much is because of the size of its population. So now question is it a fair distribution? Well, this is fair. This is more fair than this one. I can tell you that much. This is not the 100% fair. What would be the 100% fair? I don't know. But think about what is even more fair than this one. Well, maybe, for example, the full-time student. The BMCC has less full-time student, whereas City College of New York, which is an engineering school, it has more full-time student. Maybe 98% of BMCC students are part-time. Maybe 99% of CCNY students are full-time. So if you consider, you always can be more fair. So understand that this one is not fair. This is even more fair. That would be even more fair, and that's what we'll be learning today. By understanding apportionment. Okay, that takes us to the next one. This problem will allow us to understand the apportionment. So the problem states that the 5 largest colleges in CUNY received $324 million in total general education and general fund revenues. The number of full-timers in each of the 5 colleges is shown. So these are the students, and BMCC has 30,000. CCNY, that was a typo. 30,000. CCNY is 17,000. Baruch has 13,000. Queens 12,000. Hunter 9,000. And Hunter 9,000. And the total is 81,000. 81,000. Let me see. Yeah, 81,000. It looked like 30. Yeah, 81,000. Now what do we need to find first? We need to find standard divisor. How can we find the standard divisor? Standard divisor is the total the total population divided by apportionment. So what is the total population? 81,000. 81,000 divided by 324 million. 1 2 3 1 2 3 comma 0 0 0 0 0 0 cancel. What I'm gonna do, I'm gonna make it 80 and I'm gonna make it 3 2 4 0 0 0 0 0 cancel. I'm gonna make it is about 1/400. So 1/400 is the standard divisor. Okay, now what we're gonna do, we're gonna find the quota for each school. So we just gonna write a school, and then we're gonna write the student, and then we're gonna write the quota, and then we're gonna write round down, and then we're gonna write the seat. We're gonna write the money, the fund. We're gonna write the fund, the fund. Okay, school, BMCC has 30,000 people. Now quota, how can we find the quota? Now 30,000 divide by 1/400. 1/4,000. 1/4,000. 30,000 times 4,000. So 12, and then how many 0? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 3 3. Is this correct? So 30,000 times 4. 1 2 3 4,000 gives us 12. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Okay, that's great. So BMCC, and then what? CCNY is 17,000. So 17,000 times, as you kind of realize that, what am I going to do? 30,000, 17,000 divided by 1/4,000, and which gives us 4 times 17. 17,000 times 4,000, which is 68. 1 2 3 4 5 6 0. So 68 million. No, that doesn't make sense. Yeah, maybe it makes sense. Okay, this one is 120 million. This is 68 million. Okay, let's see how it goes. Baruch, 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 13,000. So 13,000 times 4,000. So 13,000 times 4,000, that gives you 13 times 4 is 52. 1 2 3 1 2 3 1 2 3 1 2 3. So 52 million. And then what? Queens College, 12,000. So 12,000 times 4,000. So 48. 1 2 3 1 2 3. 48 million. And then what is Hunter? 9,000. So 9,000 times 4,000. 36 3 3. So now we're gonna add them up. If we add them up, that's supposed to be 324 million. So 120 plus 68 plus 52 plus 48 plus 36, 324. 324, 123, 123. So then the according to just simple apportionment, the based on the population of each school, the BMCC will receive more money. 120 million is simply because BMCC has more students. Now, can we be more fair? Yes, and that's what we're gonna learn. We can be more fair. We can be more fair because now this is fair, but this is not the most fair thing in the world because, as I said, BMCC has, I don't know, maybe 98% of BMCC students are part-time. However, CCNY, maybe 98% of the CCNY students are full-time. CCNY is an engineering student. You cannot be a part-time student and pursue your career in engineering. So now this is not fair to City College because City College has 99% of the students who are full-time, and this is too good for BMCC because most of the BMCC students are part-time. So we can be even more fair by using apportionment. We're gonna learn that, especially that takes us to Hamilton. Use the Hamilton to understand apportionment. Now the example is the Brooklyn Tech have received 1,000 computers for 6 departments, and every department has different size population. So every different department should receive different number of computer, not the same number of computer. So we're not gonna divide 1,000 by 6. No, that's not what we're gonna do. We're gonna use the apportion, and we're gonna use specifically. We're gonna use the Hamilton. So now we're gonna write department, and then we're gonna write student, and then we're gonna write quota. And then we're gonna write number of computers. They should use. Oh no, round down, and then number of computers they should use. So department. The first department is physics. Physics has 300 students, and then the second department is math. Math has 600 students, and then computer science has 240 students, and then engineering has 160 students. And then chemistry has 500 students. Now first we have to find the standard divisor. How can we find the standard divisor? Is very simple. The total student 300, 600, 240, 160 and 500 gives us 1800. So there are 1800 students. So 1800 divided by the apportion, and apportion is 1000. So then it is 1.8. So 1.8 is the standard divisor. We're gonna use the standard divisor to find the standard quota. So 300 divided by 1.8. So 300 divided by 1.8 gonna give us 166.7. 600 divided by 1.8. 600 divided by 1.8 gives us 333.3. 240 divided by 1.8 gives us 240 divided by 1.8 gives us 133.3. 160 divided by 1.8. 160 divided by 1.8 gives us 88.9. And then 500 1.8. 500 divided by 1.8 gonna gives us 277.8. 3 additional set, and I will distribute this 3 additional according to the Hamilton method. So Hamilton tells us that the biggest decimal get the additional set. So I'm gonna give the next one. I will give it to the CAM. The CAM will, instead of 277, the CAM will get 278. and instead of and then the physics, because the biggest decimal, so this one is bigger than this one, so of course the physics. So 167, I'll give another additional to 167, and that is, I already distributed 3 additional seat. Now I just want to put them there, and that will add up to 1000. All right, so that was a Hamiltonian way to apportion, fairly apportion the computer 1000 computer to 5 different departments. Now this is Jefferson method. We're gonna understand the apportionment using Jefferson method, and there are 4 steps. First step, the standard divisor, then coda, then round down, and then finally we will find the apportionment. And let's get started. The problem is very simple. 1000 computer for 6 department, I believe. So write first department, and then student, and then the right quota, and then write round down, and then write apportion. Okay, so it's the department. Let's say department is, I don't know, what is the first? Physics department has how many students? 300 students. Then math has how many students? 600 students. And then computer science has how many students? Computer science has 240 students. And then engineering has 160 students. And then we have I don't know, chemistry have 500 students. Chemistry has 500 students. So let's to find the quota, we have to find the standard divisor. The standard divisor is just like before. The total student is 300 plus 600 plus 240 plus 160 plus 500 gives us 1800. So total student 1800, and total computers are 1000. So we have to find standard divisor is 1800 over apportion, which is 1000, which gives us 1.8. So 300 divided by 1.8 gonna give us 300 divided by 1.8 gives us 166.7. 600 divided by 1.8 gives us 600 divided by 1.8 gives us 333.3. 240 1.8 gives us 240 divided by 1.8 gives us 133.3. 160 1.8 gives us 160 divided by 1.8 gives us 88.9. 500 divided by 1.8 gives us 500 divided by 1.8 gives us 277.7. So now we're gonna do round down. So 166.7, 166, 333, 133, 88, 277. Now if we do that, then what do we get? 166 plus 333 plus 133 plus 88 plus 277. That gives us 2197. 2197. Okay. How can it be 2197? 166 plus 333 plus 133 plus 88 plus 277, 997. So 997, total computers are 1000, and if we add them up, is 997. So now 1.8, now this is 997, additional 3. So how can we get the additional 3? Remember the Hamilton, we just did add up by the looking at the decimal, the biggest decimal will get the additional 1 seat. Now that's not how we're gonna do the Jefferson. That's not how we're gonna do the Jefferson. We'll modify the standard. We'll modify our quota. It actually allow you to use the principle of math. For example, 16.6 supposed to be not 16, it's supposed to be 17. On the other hand, 16.2 supposed to be 16. So we'll use that principle to do the to calculate the math. So now here is the Webster method, and that is here's the problem. Use the information provided in the box below to apportion 90 seats. So there are 90 seats, 5 states. So there are 5 states, 90 seats, and their respective population of the census was conducted 1830. The modified divisor selected by, so that we have a magic divisor, and that is 49800. All right, is given, and the population is about 12 million, about 13 million. Anyway, so let's get started. We have the divisor, so our job is really easy. So if you add them up, what would be the population? 1918608 plus 1348233 plus 687917 plus 280652 plus 215739 gives you 4451149. I usually double check, but I will not double check. If I make mistake, then yeah, I should, but you should double check anytime you do this kind of thing. Now let's finding the quota. The quota for New York. The quota for New York would be very simple. The population of New York is 1,918,608 divided by standard divisor 49800, and that gives us 1918608 divided by 49800. That gives us 38.5. This is New York. Now let's do Penn. Penn is, the population is 1348233 and divide by 49800, and that gives us 1348233 divided by 49800, and this gives us 27.07. And after Penn is Kentucky. Kentucky is I don't know, Kentucky is 687917 divide by 49800, so 687917 divide by 49800, and that is 13.81. and then Vermont is, I don't know, the Vermont is 280652 divided by 49800, and that would be 280,652 divided by 49800. That would gives us 5.6. And finally Louisiana is 215739 divided by 49800, 215,734 divided by 49800. That gives us 4.33. Now we're just not gonna round up or round down, so this is 0.5, so we're just gonna write 39. This is 0.7, so it's just gonna keep 27. This is 13.8, so this must be 14. This is 5.6, so this must be 6. This is 4.3, so this must be 4. If I add them up, that's supposed to be 90. So let's see, 39 plus 27 plus 14 plus 6 plus 4, and 90, that gives us 90. Okay, so that was a step to solve the problem, and that takes us to the assessment. So the first problem of the assessment is this: Bangladesh has two states, Dhaka and Chittagong, with the population of 804 and 312 shown in the table below, and 41 sit in the parliament. Find the apportionment. So now we're gonna say that the seat is in Chittagong. In Chittagong is the seat in Chittagong is I don't know. Chittagong is 804. Dhaka is 312, and Sylhet. That's it. So 804 plus 312 gives us 1116. Now, how many seats should I give it to Chittagong, and how many seats should I give it to Dhaka? How can we be fair to both Chittagong and Dhaka? We're gonna we just find the standard divisor. Standard divisor has to be what? Standard divisor has to be, I don't know, standard divisor had to be total population and a portion. A portion is on the down, a portion is total seat. And how many seat? There are 41. So 41, and on the top I have 1116. All right, and that is and that is what? 1116 divided by 41, that gives us 27. So that gives us 27. That gives us 27. So now we have to find the Chittagong. Chittagong, we have 8 quota for Chittagong. We have 804 divided by 27. So 804 divided by 27 gives us 29.7, and quota for Dhaka is 312 divided by 27. So 312 divided by 27, which gives us 11.55. So now if we round okay, so we're gonna round down 29, and we're gonna do 11. So 29 and 11 is 40. So we're gonna give okay, so we are using the Hamilton. So Hamilton asked us to give a Chittagong extra seat because Chittagong has the more decimal. So I'll give Chittagong extra seats. So Chittagong get extra seats. So 30 plus 11 is 41. So now it is 41. Do we have any more problem? Yeah, we have one more problem. Suppose a third state, Sylhet, with population 228 join Bangladesh. So now we know state 1 is Chittagong. Chittagong, state 2 is Dhaka. Now state 3 is Sylhet. Chittagong we just saw 804, and Dhaka we just saw 312, and Sylhet it says 228. Now if you add them up, 804 plus 312 plus 228 gives us 1344. Now 1344, and then the extra additional 8. So 41 plus 8 is 49. So 1344 divided by 49 gives us still 27. This is okay, 27. Now 804 divided by 27, 804 divided by 27 gives us 29.77. 312 divided by 27 gives us just can take a look over here, 11.55, and 228 27 gives us 228 divided by 27 gives us 8.44. Now if we do calculate them, so this is 29, this is 11, this is 8, so 29 plus 11 plus 8 gives us 48. So we have 49. So who do we have to give it to? Which one has more, the bigger decimal? It's look like this one has a bigger decimal, so we're just gonna give this guy 1. So this would be 30, this would be 11, and this would be 8, and that would be 49. Okay, thank you.